In this video, I'm going to do another structural elucidation problem for proton NMR. And the degrees of unsaturation, well, if 10 carbons are present, then we would expect 22 protons, but there are only 10 protons actually in the formula. Dividing by 2 gives 6 degrees of unsaturation. This number, right, is greater than or equal to 4, which means there is likely an arene present. And the arene protons, right, are going to show up between 6.5 and 8. So that will take care of 4 degrees of unsaturation. And then there'll be another 2 to get to a total of 6 degrees of unsaturation. So there could be another 2 pi bonds or 2 rings, etc. So let's work with our arene first. So I see that there are 4 aryl signals, or 4 aryl hydrogen types: doublet, singlet, doublet, and doublet of doublets. This doublet of doublets is not a quartet. It is 4 peaks, but it's not a quartet because they all have the same height. So to have a singlet on an arene, we need to ensure that there's a proton that has non-hydrogen substituents on both sides, so it's not split by anything. So that tells me that these substituents are going to be 1, 3. We know we need 2 substituents because on benzene there would be 6 protons. On this compound we only have 4 aryl protons. So this singlet here, 1 hydrogen singlet, is that proton. And then there are 3 more aryl protons. One is a doublet, the other is a doublet, and the one that is split by both the blue and the green, that is a doublet of doublets, excuse me, that goes here. Okay, so now we need to figure out what R and R prime are. Keep in mind there were 10 carbons. We've only used 6 in the arene, so we need 4 more carbons. We still need 2 oxygens. We still need 6 hydrogens. And we need 2 degrees of unsaturation. So this 3 hydrogen singlet is likely to be a methyl group that is adjacent to an atom that has no hydrogens, since it's not split by anything. And also this is in the electronegative region, right, between 3 and 4.5. So it's very likely that this is a methoxy group, or it's 1 away from oxygen, and that oxygen is then bound once more. So that takes care of 1 of our oxygens, takes care of 1 of our carbons, so we need 3 more, and it takes care of 3 of our protons, so we now need 3 more. The other 3 protons are here. Between 5 and 6, this is the vinyl region. All right, vinyl means carbon-carbon double bond. So that's going to take care of 1 of our degrees of unsaturation. And it takes care of another 2 carbons. The vinyl region here has 3 protons between 5 and 6.5. Right, this is a little bit larger. So what I see is that this proton here is diastereotopic due to cis trans compared to that proton. So they split one another, and they are both non-equivalent to this proton. So one of these doublets of doublets belongs here, one belongs there, and the other belongs here. Okay, you wouldn't have to know exactly which is which in this course. Also, because they are all doublets of doublets, they are each splitting each other, but there could be no hydrogens here. Otherwise, the blue proton would be more than a doublet of doublets. It would be more complex. So we've used all of our hydrogens, and we now have it down to 1 carbon, 1 oxygen, and 1 degree of unsaturation, which tells us C double bond O. And that carbon will have no hydrogens on it. We've used all of them. So if you want to take these puzzle pieces, the benzene ring, the vinyl group, the methoxy, and the carbonyl, you can construct them in 2 ways, or construct the molecule in 2 ways. First of all, the vinyl group has to be at the end, so perhaps it's hanging off the arene. The carbonyl needs 2 bonds, so perhaps that's going to be on the other position. Sorry, they are 1, 3 in this example. And then that methoxy could be an ester. Alternatively, another possible structure would be having the methoxy instead of the vinyl, the carbonyl in the form of a ketone, and then the vinyl group adjacent to the carbonyl. In this course, okay, it'll be very hard for you to distinguish between 2 of those, and you'd have to know a lot about specific chemical shifts of styrenes as opposed to alpha beta unsaturated ketones. So on this exam, and at the level we're at now, either of these would be a correct answer for this exam. Okay, so for more practice on structural elucidation, you can visit Unit 1 of my Orgo 2 course guide at chemguides.com.